So what we're going to talk about today is using MySQL Document Store with Node.js. This is something that I actually didn't know a whole lot about until I actually started working as a developer after MySQL, and it's something that I've actually become quite smitten with. But before we get into that, this is the obligatory I love me slide. I have been a developer for over 20 years. In that 20 years, the only thing that has remained constant in my stack has been MySQL. I have the first job I ever had where I was a web developer. We used MySQL in the back end, and I actually have projects that I use now almost on a daily basis that are using MySQL in the back end as well. As I noted earlier, I am the MySQL developer advocate for Oracle. I am an avid golfer. I'm a diehard Giants fan, and I have the best office mate in the world, and that is my dog, Murphy. Murphy spends pretty much all day, every day in the office with me on the days when my wife is actually working as well. So let's talk about what we're gonna cover in this talk. And the first thing I want to talk about is the NoSQL versus relational databases, the pros and cons of each. Not all of the pros and cons, some of the big pros and cons. Going to talk about exactly what MySQL Document Store is. And then we're going to talk about how MySQL Document Store is actually architected, or the anatomy, what are the different parts. We're going to discuss how we can actually access MySQL Document Store. I'm going to go take a little bit of a detour and talk about MySQL Shell, which is one of the easiest ways to actually start learning some of the methods and functionality of the document store. And then we're going to dive into talking about how to connect MySQL Document Store with Node.js. And then we're going to finish up with some examples of how to use the CRUD API, as well as how to use raw SQL to query our JSON documents. So quite a few years ago, the NoSQL databases started coming around. The big one that people use now is MongoDB, but there's been quite a few over the years. And I'm going to be honest, I don't want to say I was against them. I couldn't appreciate the benefits that they offered. And over time, and again, this was actually before I started with Oracle, I started to appreciate some of the advantages you have when you do use NoSQL and storing JSON documents. So some of the advantages of using NoSQL is you have a faster development time. If you don't have to worry about making database changes, so for example, if you're developing a new product or a new project and you're starting from scratch, it's going to be a lot easier for you to ramp up and get development going if you don't have to worry about constantly updating the database. You can just change your schema and throw it into the NoSQL database. It's easier to modify the schema. You don't have to run SQL queries. You just store the JSON differently. And all of the NoSQL databases have a simple CRUD API. Some of the cons, and I don't even know if these are really cons because it's kind of part of the nature of the beast, is the data is unstructured. And in some cases, that's not necessarily a bad thing because there is some data out there that is not structured and is not necessarily a good fit to store into a relational database. But one of the other difficulties is running ad hoc queries. If you have a NoSQL database and you try to run reporting, it's very, very difficult to do. It's not impossible, but it is difficult to do. Now, when we're talking about relational data, one of the pluses is that data can be structured and organized. And this was the thing that I couldn't let go. I used to be, all my data had to be structured and I had to have things in related tables and, there had to be foreign key relationships and indexes and all. And I realized that sometimes that actually is a detriment, that you don't necessarily need to do that. It's also easier to run queries on reporting. So if you have nicely structured data and you have things stored in tables where they're related properly and you have foreign keys, it's easier to run queries if you need to run aggregates or other types of reports for the data. Some of the cons is there's a little bit of a slower development time, depending on how big your team is or whether or not you have a centralized or decentralized database. Some teams don't have people running local databases for their projects. So as you need to make changes to the schema, it takes time for those changes to propagate through not only the development environments, but when you start to deploy, you have to make sure that you're taking into account those changes as you deploy to your staging or production environments. And then finally, as more related data is added, so as your schema starts to grow and you start to add more tables that may relate to other tables, the CRUD operations could become more and more complex. So you might wind up having to write to multiple different tables rather than just one table. Again, the cons there aren't really cons. For both of those, they're kind of like the nature of the beast, but they are things that I think are maybe a little bit that people need to get over in order to appreciate both for NoSQL and relational data. So now what if I told you you could have the best of both worlds? So if we could take the best of both of those things, of a NoSQL database and a relational database, that to me is pretty cool. And that is something that MySQL actually offers. So the way we offer that is through MySQL Document Store. And the MySQL Document Store is a JSON document storage solution built on top of MySQL. The data is actually stored in a MySQL table. It's just the CRUD operations are abstracted out, and it uses an API. The underlying storage engine is InnoDB. And it actually uses the JSON, the native JSON data type in MySQL to store the actual JSON data. And one of the cool things for me is the fact that this whole thing is ACID compliant. Because it's built on top of the InnoDB storage engine, MySQL Document Store is fully ACID compliant. And as I mentioned before, there's an easy to use CRUD API. And I try to avoid using terms like, hey, it's easy, it's simple, but it really is, because there's literally 4 methods that you use to create, read, update, and delete data in the MySQL Document Store. So the anatomy of the MySQL Document Store, here we're kind of talking about the nomenclature and what the table is made up of. So in the nomenclature of MySQL Document Store, there is something called a schema, which in MySQL parlance relates to a schema or a database. MySQL Document Store, we talk about a collection. In MySQL parlance, that would be the same thing as a table. And then a document would just be a row in that table. Now, when you create a collection, and I'm gonna show you how to do that in a moment. In the background, it basically just creates a table with 3 columns. And those 3 columns are _ID, which is a var binary data type. There's a column named doc, which is a JSON data type. And then there is an _JSON _schema column, which is also a JSON data type. Now, something to keep in mind with the JSON schema, you may be like, well, wait a minute, isn't NoSQL supposed to be schemaless? And that is true. That's one of the advantages, that it is schemaless, but it also affords us the ability to validate that the schema matches certain criteria. So for example, let's say every document you have in a particular collection needs to have a certain property. So there's a property that is required in every document. We can actually set that in the JSON schema column, and it will actually validate that when you insert a document into that table, it validates, or it makes sure that that particular property is there. And also, I should note that you can actually add indexes, and it's not something I'm going to cover here because there's a lot of stuff to talk about. But when you create indexes, you can actually say, I would like to index the values of this particular property. And when you do that, MySQL actually creates another column in the database, and it uses that through the API when you need to look up stuff. So if you want to create an index on the name property of an object, it will create a new column, and when you search based off of the name, it actually uses that index column rather than the doc column searching through the JSON data. So how do we access the MySQL Document Store? We access it through what we call the X plugin. And this is actually something that is part of the server product itself. And if you're wondering if you need to go out and install it, as long as you're running higher than 8.01, which I really hope if you're running MySQL, you're running higher than 8.01, it's already installed by default. So there's nothing else that you need to do in order to prepare your server to be able to use MySQL Document Store. And we use the X protocol through the X plugin with different MySQL connectors. And connector here would kind of be the same as driver in the fact that you have a connection string that looks a whole lot like a JDBC connection string. And these connectors are available for Java, C++, Python, .NET, MySQL Shell, which we're going to talk about in a moment, and then finally Node.js, which is what we're going to be talking about for most of the presentation here. So a slight detour into MySQL Shell. MySQL Shell is a command line interface for managing MySQL instances. It goes beyond just being able to create tables, drop tables, run SQL queries. You can actually manage MySQL Document Store schemas and collections, including importing data. As a matter of fact, the code that I'm going to be using in this demonstration today is up in a GitHub repo that you'll see the URL for later. And the instructions in the GitHub repo actually have you use MySQL Shell to import the data into your collection so you have it, and you can then run the examples that are in the project. But you can also create and manage MySQL clusters. You can create and manage MySQL replication, and you can create and manage MySQL replication clusters, all through a command line interface in MySQL Shell. It really is a pretty powerful tool. And you can also run SQL queries. One of the cool things that came out recently is there is actually MySQL Shell for Visual Studio Code. And not only do you get all the advantages of MySQL Shell, but it also has connectivity to the Oracle Cloud Infrastructure. So if you have an OCI account and you install Visual Studio, the plugin, the MySQL Shell plugin for Visual Studio Code, it will actually look at your OCI configuration information and then go and pull your information. So you can pull up all the instances and storage and pretty much everything that you have available to you or set up in Oracle Cloud Infrastructure, you can see through VSC using the MySQL Shell plugin. So real quick, show you how to use the MySQL Shell plugin. You need to go to MySQL. I forget the exact URL. And now that I think about it, I'm not sure the URL is on the last slide here. But you basically run the command MySQL sh, and MySQL Shell will start. First thing you'll see is it actually shows you what version of the shell you're running. Forgive me, I'm not running the most recent version, mostly because the server that I use is not running the most recent version of MySQL yet. I haven't had the opportunity to update it. And then you see like the trademark information, and then it tells you how to get help and how to quit. And then you'll see this nifty little command line here where it's got the MySQL and it says JS. And there's a couple of different modes in the MySQL Shell. There's the JS mode, which is what starts by default. And then there's the SQL mode, which I'm going to show you in a second. And then there's also a Python mode. So you can actually run Python code inside the MySQL Shell to make connections to your SQL Server or to the document store like we're doing here. So the first thing we need to do is we need to actually connect to an instance. And we use /c to say connect. And then here, if you see, it looks just like a JDBC URL. We do MySQL X because we're using the X protocol, // and then username. You could have password at server. And then if we weren't using the MySQL X protocol, if we just had MySQL : // we would do : and then port number 33060. That's for the X protocol. But because we actually specify MySQL X as the protocol, we can leave the port number off. And then you'll see it actually says it's creating an X protocol session connecting to Scott at localhost. It's fetching the schema names, and then it tells you what your connection ID is, and then what I think is cool is it actually tells you what your server version is, so you can tell right away what you have. And then you get, hey, it tells you there's no default schema selected, type /use or /u, and then the schema name to set. What we're going to do, if you want to create a schema, once you're connected to your MySQL server, you have a session object that is available to you. And to create a schema, you just do session.createSchema, and you pass in the name of the schema. So here we're actually going to be creating a schema named demo_schema. And we hit enter, you'll see underneath it just echoes the name of the schema. If there was any problem with it, like if one already existed by that name, you get an error message. But when you don't see anything, you just see the name you created, then you know that you created it successfully. So now that we have our schema created, we do /u or /use demo_schema. And that's basically the same thing as like use database name in raw SQL. And we get the message that says default schema is now demo_schema, and it is accessible through DB. This means that when you want to run commands, you don't need to type you don't need to keep remembering the schema name. You can just use DB as the object, and that has all the information related to that particular schema. And if we want to create a collection, and remember, a collection is just a table, we do db.createCollection and then demo_collection. And then again, when it's successful, it's just echo back out to you onto the screen. And if we were to look into, if you want to see what this looks like, what we do now is we do /SQL, which we're telling MySQL shell we want to switch to SQL mode. So once we do that, you see that's item 6. It says you're switching to SQL mode, commands end with a semicolon, and if you don't end it with a semicolon, it will tell you. It will remind you that you need to do it. And from here, we can run SQL commands. So we could run a select. We could do select star from table name if we wanted to. But what we're going to do is we do describe demo collection. And what that's going to do is that's going to spit out the columns that exist. And you'll see here that we have the doc column, which is type JSON, _ID, which is a var binary, and then _JSON_schema is also a JSON type. The first two are null. The second one's not, and it's also set as the primary key. So I would say MySQL shell is a great way to learn some of the commands that are available within MySQL Document Store without having to connect it to a language like Node or Java or C++. You can actually just type the stuff right in the command line and you'll get results back. So we could actually do db.collectionname.find and it will actually return information right in the command window. So now what we need to do, the first thing we need to do in order to connect MySQL Document Store to Node.js is we need to install it. And it's very easy to do. You do npm install @mysql/xdev API. And then it'll go through and it'll install all the different properties all the different related packages that you need. So before I get into how we actually get into the node, I want to give you a little bit of a background on the project that we're going to be using. It is a very basic, bare bones Node Express application. I set this up so we can just have, there's a few endpoints that we're going to hit, and it's a one-page file. So there's just one file in the source. I probably wouldn't do that in production. I probably would have broken out all the MySQL Document Store interaction into a separate file. But I wanted to be able to make it easier for people to see, especially if it's somebody who's just maybe starting with Node or just starting with MySQL Document Store, so they can see how the endpoint definition and the actual function definitions are related. So the first thing we need to do in our application is we need to require the dev API. So again, we use require @mysql/xdev API, And then in this particular case, the MySQL X variable will hold the value of an instance of the XDev API. So from there, we're going to be doing other stuff to handle our connection using the variable MySQL X. The next thing you need to have a connection string. And in the code that I wrote, in the application that I wrote, pretty much the username, password, server, port, and database name are all passed in through a .env file. That there's a template that you can use, and you can actually substitute your own information if you want to. But the connection URL here, it says it's MySQL X / user / password at localhost / port number / connect collection name. I'm sorry, schema name. And again, if the item is 1, if you do MySQL X, you can leave off the 33060. You don't need it because it'll use 33060 by default. But if you just put MySQL here, in order to connect to the document store, you need to then put 33060 as the port number. But that is optional if you use MySQL X. So the next thing we do is we set up a connection pool. And I actually did this because I like the idea of having connection pools so that we're not constantly overburdening the server, and it does make it a little bit more performant. And here you'll see we're using the MySQL X variable for the first time, and we're doing get client, and we pass in the connection URL, which is a string we just created. And then you'll see after that we pass in a JSON blob where we have pooling. We're enabling it. The max size is 10, so the most number of threads that'll be running at a time is 10. The max idle time is 20 seconds, and the queue timeout is 5 seconds. And that's pretty much it. If you put that code into your Node project and you run it, it will actually create a connection to your MySQL database using the X protocol, and then you'll actually have a pool that you can pull session information, or you can pull sessions from. So before we go any further, I want to talk about the schema that we're actually going to use for the demo. You may have noticed that earlier in the beginning when I was talking about myself, I said that I'm an avid golfer. And one of the things I do is actually manage a golf league. I have been doing that now for well over 10 years, and we have 80 golfers that play 2 nights a week for about half the year. And I decided to use the data from that particular from the golf league website as part of the data for this particular presentation. I did clean up the information, so the only people in here that are actually real golfers in the golf league is anytime you see any data that has my name. So anytime you see Scott Stroz, that is actually me. That is actually a score that I shot on the date that it shows in the data. Everything else, the names have been obfuscated. But you'll see we have the ID. And again, this is generated from the document store when you create a document. The date, which is the date I played. The score is what I shot. The course you'll see is actually a property with it's an object where we talk about the name of the course, whether it's front 9 or back 9, the state, the city, and the par for the course. There's the first name and last name. And then there is an array of hole scores. And what this information is, it has the par, so whatever the par was for the course, for the hole, the score that I shot, what number the hole is, and what I scored in relation to par. So here you'll see I had it was a par 4. I got a 4, so my relation to par is 0. Now what you might notice is that these numbers, so we have the number, so this is the hole, this is the 11th hole, and then it's followed by the 14th hole, and that's not actually the way golf courses work, because typically the 12th hole follows the 11th hole. And the reason why that the data is returned this way is because the JSON data type in MySQL actually stores the data as a binary, and it reorganizes stuff to make it so that it's more efficient. Because this actually isn't the order in which these keys were put in either. when it was added. The order gets changed so that it's a little bit more performant. It makes it a little bit easier to read. So when we get this information on the front end, we would probably have to make sure that we ordered that array so that we're displaying the information in the order that we wanted to, or we could even pull it back then. So let's get started. The first endpoint is called list. And all this is going to do is this is going to list every score that exists in our database. So the application, we're listening for a GET request with /list on the end. When that comes in, you'll see that these are all async and await. And the reason why that is because all the calls to MySQL Document Store are asynchronous. So we need to make sure we're accounting for that. And we're going to be calling a method called list all scores. And that's going to return basically just an array of scores. And what's going to be returned from our API, every one of the calls that we're going to be doing for the rest of the night is there's going to be a count property that tells us how many items there are. And then there's going to be, they're not all going to be scores, but there's going to be another property. And then that's going to be the array of the information we're going to use. So now what does this look like for the MySQL Document Store? So you see, one of the first things we do in list all scores is we call pool.getSession. So this is actually getting a database session from that pool that we created when the application started up. And then once we have the session, we actually need to get the schema or the database name. So from there, we do session.getSchema, and we pass in the database name. And again, in the code that I have, database name is actually pulled in from the environment variables that are set in the .env file. And then the last thing we do is we need to get the collection from the schema. So we do db.getCollection, and we pass in the collection name. Again, collection name is passed in from the .env file. So then now that we have the collection, what we do is we just call collection.find. Now, one thing I want to warn you is if you have a lot of records, like I have in this particular table, collection.find will return everything. Okay? And in the Node.js, when we're dealing with the Node plugin for MySQL, what we do is we need to call .execute. So we do collection.find.execute, and then we have basically, whoops, sorry, I didn't mean to click. No, go back. There we go. So what we do here is we have a closure where we're passing in the score. So this is going to, when the results come back, it's going to iterate over the results of the query, and then it's going to add each row to the array that we have. And then the last thing we do before we do anything else is we close the session. And I did it again. Sorry. That's actually important because if you don't close the session stays open, you could run into performance issues down the road. And then we're returning the scores. So let's see what that looks like. So here we have localhost, and I have the application set to run on port 3001, and you see we do /list. When I click send, you see it actually came back pretty quickly. It pulled back in just over a second and a half. And you'll also notice that there's 17,477 scores that are in this database. Postman's going to take a while to clean that up, to display it nicely, but we can see that there's almost 17,500 scores in the database. So this is actually data in the Golf League going back to 2013. And hopefully by the time we come back to that, it will be all nice and formatted. So obviously, when you have a lot of data, you don't necessarily want to return everything all the time. So what we're going to do here is we're going to create an endpoint that is also list, but has a limit that we can pass into it. And you'll see here, we call a method called limit all scores, and we're actually passing in the parameter limit. In Node, when you have a parameter in the URL, it's the request argument .params.limit. The way this is set up, it's actually mandatory. If we wanted a parameter to be optional, which we'll see in a little bit, you put a question mark at the end. But in this particular case, we want to enforce the fact that it has a limit, because if it doesn't have a limit, it's going to return everything like we just saw. And then in the limit all scores, you'll see that we're passing in that value, that limit. And the way we use that, I'm not going to go over the creating the session and the DB and the collection on every slide, because it's all the same from now on. These 3 lines of code pretty much exist in every demo from here on out. There's a couple that it doesn't, but there's a reason why it doesn't. So here you see we call collection.find.limit, and then we pass in that value. So whatever value is here, it's just like calling limit on a query. So if you're writing a MySQL query and you wanted to limit the results to 5, you put limit 5 at the end. And the same thing here. If we want to limit this to 5, we pass a value 5 in, and then we're only going to get 5 results. You can also use offset. There's an offset property, or an offset method as well, so you can actually set up pagination. And let's see how that looks. See, look, now it's all pretty. So now we have the limit all, and we're passing in the limit of 100, and we click send, and you'll see that the count is 100, and it shows a lot fewer scores, and it also returned a lot faster. And just to show that this is actually working, I will do 12. So when we send that, you'll see now the count goes to 12, and you'll also see that the result is a lot smaller than it was. So what we're going to do now is we're going to talk about how we can sort data and how we can actually restrict what data is returned from the server. So what we're doing here is we create a new endpoint called best scores, and you'll see we actually have the limit set as optional. And what this next line says is if the parameter limit doesn't exist, or if the parameter limit does exist, use it. If it doesn't, we're going to use the default result length. And this is actually a value or a variable that is set in the code, and it's set to 50. So from here on out, anytime we don't pass in a limit where 1 is optional, it will default to 50. And it's actually calling the get best scores method, passing in the limit of 2. So in the get best scores method, you'll see that we have the sort method. And in this particular case, we pass in an array. And the array is basically would be what we would use for our order by clause in a MySQL query. So what we're doing in this particular query is we're sorting by the score ascending and the date descending. So what's going to happen is we're going to get the lowest scores first. And if 2 golfers got the same score, it'll show the most recent one first. And then if you look at item 4, excuse me, you'll see that we're also using the fields method. The fields method also takes an array, and the fields method, we're basically telling it what properties to use. So we all in this particular method, we only want to return the first name, the last name, the score, the date, and then if you look here, we're doing course.name. Remember, course was actually an object that had several properties, one of which was the name. So we can do course.name and then alias that particular column as course name. If we didn't add the as course name, course.name would actually be the property that shows up in the result. And that just doesn't make a whole lot of sense. And let me show you what that looks like. So here's the best scores. I'm not passing in any limit. You'll see it defaults to 50, and you can also see the results that come back. It's the date, the score, the last name, the first name, and here you can see the property is actually course name, which is the alias that we used rather than course.name. And then if we want to limit that, we can, let's just say we want to see the 5 best scores. Again, you see it shows it's the 5, and you can see the result is actually quite limited there. Now, when you use a condition inside of a find, it's kind of like defining, I shouldn't say it's not kind of like, it is like defining a where clause. So what we're doing here is we're actually doing collection.find, where the score, so this is the score property of the object, is less than course.par. So what this is going to do is this is actually going to return us all the scores when the golfer shot below par. And here you'll see of the 17,477 rounds, only 145 of them are below par. And you can see the score, the name, just like before, it's the date, the score, the name, first name, last name, first name, and then the course name. And I'm not going to scroll through all of them because my name's not there. So just like when we run queries using other languages, we don't really want to use user input in our queries. So a lot of times we have to do is we have to do binding to say, hey, or parameters to be like, hey, this particular parameter is an integer or a string or whatever. So this way we're kind of making sure that we're keeping clear of any type of SQL injection. Because remember, this is really just a SQL table under the covers. And here we have an endpoint called getByScore, where the score value that's passed in is optional. And if it's not passed in, we actually set it to 36. And then you'll see that we call getByScore, and then we do parseInt score, just to make sure that what's being passed in there is actually an integer. And then you'll see in our find, here we now have score equals :score, which is kind of standard parameter binding syntax in a lot of different languages. And then you'll see we have the dot bind, and then we have the string score. So what's in the first argument needs to match what's after the colon in the binding, and then comma value. And if you have more than one value that you need to bind, you just call bind again. So if there was 2 parameters here, we would call bind again and pass in the string that we're looking for the parameter, and then the value that we want to use in its place. And then you'll also notice that in the fields method, I'm actually calling a MySQL function, concat. So instead of returning the first name and last name as 2 different fields, we're actually concatenating the first name and the last name and returning it as golfer. So in your fields definition, you can not only alias properties inside of your data, but you can also call MySQL functions on that data. And we're going to see more examples of that coming up. And then getByScore, I'm passing in 45. So we're going to see all the golfers who've had a score of 45. And lo and behold, look, I'm one of the first ones there. And you'll see here's that concatenation. So the property name is golfer, and it concatenated first name and last name. So now we're going to talk about having, like, if you want to have a binding when you're doing when we're doing a like search in the document store. So again, first thing we're doing is, because last name is not required, we do the shortcut here that says params that last name doesn't exist, basically use the empty string, and then we pass it into the method called getByGolfer. And in the getByGolfer method, you'll see that we have find, where lower last name, like last name parameter. Now remember, I did it again. I'll get used to that. MySQL, for the most part, is not case sensitive. However, JSON and JavaScript are case sensitive. So if you searched for the string STROZ all lowercase, it would not match my name in the system because it's got a capital S in all the data. So we need to make sure that what we're searching for and what we're searching are the same case. So in this particular case, we use the lower MySQL function for the last name property is like parameter last name. And then in the bind, we pass in last name, but then because this is JavaScript now, we do last name dot lowercase, and then we add the % on the end. So we basically can do a like search for last names that begin with the characters that we're typing. And if you see here, we do getByGolfer and we're searching for Stroz. And you'll see what comes back is we have 208. I've played 208 rounds in the golf league. And again, they're sorted by date. And this is actually the entire document, so it has all the score information as well. If we do that search by Cam, you'll see there's 73, and it will actually return Raymond Camden. And yes, Nolan, he knows that I put his name in here.
I didn't say anything.
Okay, another example is we're going to use group by. So what we want to do now is we want to get the average score per golfer. And we actually have an optional parameter here where it's based on the year. So what's going to happen is if the user provides a year to the API, we will get the golfer's average score for that particular year. If no year is provided, then we get all of the years. So you'll see here we're passing in year. Now remember, I didn't do any logic checking to see if it exists. So it's possible undefined can be passed into this method. And in the DB find, now here, this to me is like one of the cool things about using MySQL Document Store in JavaScript, because we can kind of mix and match the syntax. So if we break this down, we're saying, hey, if year exists, then we want the find criteria to be where year date equals year. And if year doesn't exist, then the criteria is where date is not null. So basically what that's saying is if we were to pass in the year 2022, then the string being passed to find would be year date equals 2022. If we didn't pass in a year, then the string passed to find would be date is not null, which means it would pull back everything for, it would pull back all the golfers for all the years. And if you look here, we got another MySQL function that we're using. Actually, we're using two of them. It's nested. We're using average score, and then we're rounding that to 2 decimals. And then we're actually using count. So we're actually counting the number of scores that are for that particular golfer. And then you see here, we're doing group by. And again, in this particular case, because we want to group by last name and first name, we pass an array. If we only wanted to group by one name, by one property, we could just pass it in as a string. We don't need to pass it in as an array. And the same thing goes for sort and fields. If you only want to return one of those, you don't need to do an array. You can just do the single string. So what we're going to get here is we're actually going to get a list of all the golfers, and then it'll show their last name, their first name, their average round, and the number of rounds they played, either for the particular year that's given or for all the years that exist in the system. So if we do get average score per golfer, oops, you'll see here, this is my average, again, number of rounds, 208. So this, we know now based off of the last API call that this is all years. But if I pass in 2022, we can see how I did this year. You see, actually, I did a little bit better this year than I did overall in the entire time that I played in the league. And you also see that the number of rounds is 20. So I played 20 rounds in this particular year, and my average is 46.95. So now, this particular endpoint that we're dealing with is now we want to find out information. Everything we've dealt with so far, we've been talking about the golfer. And remember, the golfer, the name, and the score were main properties of the particular document that we're dealing with. But now we want to look at course data. So now we need to look at grouping this information by a child property. And what we're doing here is we're actually getting the average round score for the course. We're getting the lowest score and the highest score. Now, I have to cast this as an unsigned because for some reason, and I don't know why, and I've reached out to the team to try and find out why, is if I just called min score, it comes back as a string. It doesn't come back as an integer, or it doesn't come back as a number. So that's why I cast it as an unsigned. It's an unsigned integer. And then we do count score as number of rounds. And then here, the group by, we're actually grouping by course.name. So this isn't one of the main properties. This is actually a child property. And if you had like multiple nested objects, you can continue that path all the way down to group objects by that. And then to get the course data, you'll see here, we have the average score is 46.83. And this is for Locust Hill Golf Course on the front nine. What's the course that I play? The lowest score is a 29. The highest score is an 89. Yes, those are actually real scores. And then the number of rounds that have been played has been 6,800. And if somebody is astute and they're looking and they say, hey, why is this 6,800 and 6,350? Shouldn't they be the same? It's because sometimes we've had rainouts that we couldn't make up, so we played more rounds on one than the other. Okay. So now we're going to talk about what I think is the really, really, really powerful thing about MySQL Document Store. And that's being able to use raw SQL. So we're really not using the document store now. We're actually going to be hitting the underlying table as if we were running this query in, MySQL Workbench or MySQL Shell under SQL mode. And there's a lot here, and I'm sure you guys are like, wow, there's a lot of red dots with numbers. I'm going to break those down as easily as I can. So the first thing you'll see, number one, is we're actually calling the session. So we are pulling a session from here, but then we're not pulling in the schema or the collection. We're only pulling in the session. And then you'll also see that we're creating a string called SQL. And I'm going to break down what's inside that SQL in a second. But at the bottom, you'll see that in order to get the query results, or we create a query object and we do await session.SQL and we pass in that SQL string that we create. And then we call query.execute. And again, we have a closure where we're passing in this particular case, ace is it's an instance of a row in our result, and we're pushing that into the aces array. Again, we call session.close, and then we return the aces. So let's break down this query, because this is kind of a monster. One of the advantages of using a JSON data type is the fact that MySQL, and this isn't just unique to MySQL, every database management system that has a JSON data type has the ability to peer into that data. And they have a slew of JSON functions that allow you to manipulate and use that data. MySQL is no different. So this select statement, it starts with select JSON object. Now, what the JSON object method does is it returns a JSON object. And we are actually defining the JSON object. Excuse me, the JSON object actually accepts pairs of arguments. So you either have 2, 4, 6, 8, however many you need. You can't have 3, because each pair of arguments has a string that's passed in, which is this is actually what's going to be in the result, and then the value we're going to use. Now, in this particular case, you see this little, it's the hyphen greater than. I don't think there's actually an official name for that particular traversal. But what we're doing here is we're saying the property first name is going to equal the first name property in the document. So when you have that type of operator, everything what's before the operator is the column that we're going to be using. So remember, because it's a MySQL document store, it has to be doc. That has to be the column name. And then we have the operator that says, and this is the path we're going to use, where $ is the root. So here we know that we're using the first name property of the main object. And then we have the same thing for last name, where we're saying it's the doc, and then we have the path operator going to last name. Date, doc, path operator, date. And here we got course name. And you'll see we have doc, the path operator, and here we say the path is $.course.name. So we know from looking at this that there's a property called course in the main object, and that course has a property named name. And then we have a property called holes. And the value of holes is actually going to be the result of a function called JSON array ag. And what JSON array ag does is it will actually return an array, a JSON array of, it's not aggregate data in terms of like how sum or count or average is aggregate. It basically, if you do like a join on 2 tables and the join causes like almost duplicate rows to be returned, but there's maybe one column where the values are different between the 2 rows, this actually will take that information and concatenate it. So it's kind of like a group by, and it returns that information as a JSON array. Now we can actually have JSON array ag can actually return single values, whether they're numbers or strings, or you can actually return JSON objects. So here we have another JSON object where it has 2 parameters. It's got whole number and it's got par. And you'll see here where we're talking about a value in a table called whole scores with a column of number, and then we have the table called whole scores with a column called par. I'm going to show you where we're going to get that right now. There's another cool MySQL function called JSON table. And what JSON table does is it will actually deconstruct a JSON blob and create a MySQL table out of what we tell it to. And it takes a couple of arguments, and the first one is, what column name are we doing? Again, because it's MySQL Document Store, it's the doc column. The next argument, which is item number 11, is the path that we want to use in that object. So here we have $.whole scores, and then you'll see we have this bracket star bracket. And what that's telling JSON table is to use the value of the whole scores property as an array and use all of them. And then we specify which columns we want to use. So here we want to use the score, we want to use the number, and we want to use the par. And you'll see here we say score int. So that's saying that the value is actually going to be an int. And then path, you'll see is $score. Now inside the columns block here, this $sign is not referring to the root of the object that we're talking about. So this is not the root of doc. This is the root of whole scores, the elements that are inside the whole scores array. So we have $score, and then we have the number, which is an int, and the path is $number. And then we have par, which int, and the path is $par. And then you'll see that we're casting this as whole scores. So this table right here is the result of this function called JSON table. And it actually creates a join in much the same way where if you do select star from golfer, league, it'll create the joins where it can. So we now have two tables that are joined, and one of them is whole scores. And that whole scores contains the score, the number whole that we're dealing with, and then what the par was for the whole. And in the where clause, we're saying where whole scores dot score equals 1. So we want to get all the holes in one that existed. And you'll see and then we do a group by, and again, we have that path operator. So we're grouping it by the last name property and the first name property, and then we're ordering it by the date property. So now what's going to be returned here is we're going to have, let's go back up here. We're going to have the first name, the last name, the date, the course, and what hole the hole in one happened on. And I set this up in this array. It hasn't happened in my golf league, but I know it could happen that somebody could get 2 holes in one in the same day. And I wanted to make sure that we didn't have duplicate information for different days. So this will actually show us the day and whatever holes that they have. So let me show you what that looks like, because it might make a little bit more sense seeing it in the data. So we call it get holes in one, and you'll see here, we now have, there was on May 26th of this year, Glenn McMullen had a hole in one on the par 3 fifth hole at Locust Hill Golf Course, the front 9 of Locust Hill Golf Course. If he happened to get another hole in one, this block would be duplicated with the information for the second hole on the same day. Then you'll see there's another one from April 21st, Jimmy Tringali. And then we had another one last year, and then the year before. They don't happen very often. It's kind of weird that we've had two, and we've had 2 this particular season. So imagine trying to do that in just in a NoSQL database where you didn't have access to actually dive into the information the way we had. Again, not impossible, but I think it'd be a lot more difficult than what we've shown here. So I have another example. One of the things that I wanted to try and do, and this was me having, thoughts of what would be cool data to show. I was thinking to myself, if we took the best score from any golfer on every hole, what would that round have looked like? So now we have to rip out the the whole scores. We have to get the best whole scores and then wind up doing a sum on that. And so this is the way this is the way that query looks. I'm going to break this down again. You'll see here that starting with the item number 1, we use with ag scores as. Basically what I'm doing here is I'm actually taking the JSON data that we have in the doc column, and I'm putting it into a common table expression that we can then use in a query further down. And what we're doing here is we're saying, hey, we're going to select the course name and alias it, of course, and then the lowest score and the highest score and the whole number from scores. And then we have a JSON table where we have, again, doc, the whole scores array, the columns we're using our score and number, and we're aliasing that as scores, grouping it by the course, and then the number, and then ordering it by the course and the number. And I needed to do that to make sure that the information was grouped correctly. And then the main query, so this is our common table expression right here, is everything from select all the way down to here. This is our common table expression, which is actually going to make that information available to us in much the way a table would be. So now we're going to do select JSON object, course name, and we're going to, the property is going to be course name, the value is going to be course, and then best score is going to be the sum of the min score. So what we did in the CTE is we actually took the lowest score of every hole, regardless of what golfer played, and then in the main query we just add them. And then you see the from ag scores, that's the common table expression name we gave it as ag scores, and then we group it by course and we order it by course. And those results look like this. So you'll see the Clustered Spires Golf Club, the back 9, the best score, which would be the best score if you took the best score from every golfer on every hole, they'd have a 30. The front 9, they'd have a 20. The one that I think is impressive is Locust Hill Golf Course, the front and back 9. The sum of the best scores of every golfer on every hole is 20, which means almost every hole, somebody at some point in the golf league history has scored an eagle on it. There's actually 4 holes that it hasn't happened on, and the eagle is 2 under par. So again, that shows a lot of the power of the document store, where we can actually dig underneath and use raw SQL to pull some of the information. So all the stuff we've talked about so far, we were talking about retrieving. What we're going to be talking now is creating, and that is basically the add method. So in this particular endpoint, we have the endpoint is /score, and it's a post method. And you'll see that we call add score, and we pass in the request argument .body. So what we're going to be doing here is we're actually going to be passing the JSON we want to save as the body of the request, and that body of the request is actually going to be passed into the add score method. And you'll see that we specify the score as an argument, and then we do the same thing. We have session DB collection, and then we do collection.add, and we just pass in that JSON object and call execute. And that's it. That's how you insert a document into a JSON document store. And to show you that, here we have add score. You'll see here this is the body of the item. I'm passing in the ID. You don't have to pass in the ID. It will actually be generated. The only reason why I'm passing in the ID here is so that in the next examples, I don't have to worry about copying and pasting the ID from when it's created. So if you pass in an ID, it'll use it. If you don't, it'll create it. So when I send this, you'll see I get back a success equals true. And you'll see it was August 30th for a golfer named Skippy Dinglehoffer. Interesting side note, if any of you ever happen to work in a system where there's something in the code or the database where there's a user named Skippy Dinglehoffer, I was probably there. That's probably me. So to verify that we added, what we're going to do is we're going to call the get by golfer and then pass in the Dinglehoffer last name. And you'll see here that we do have, this is count of one, the scores. There's August 30th. There's the score and the Skippy Dinglehoffer, but there's something missing. We didn't pass in the actual whole scores array. We're going to take care of that when we do our update. Which we call modify. So I tried to figure out, I tried to do the, instead of CRUD, use the actual first letters of the message that we use, but it didn't have a good sound. So whole scores is the endpoint. Again, it's a post. We're passing in the request body into the add whole scores method. And here you see we have, oops, I did it again. I got to stop hitting that. Sorry. The data is being passed in. Here you have collection.modify. And then you see we have underscore ID equals ID. And you can tell that we're doing a parameter or a bind here. And then you have .set. And we have .set whole scores is the property we want to set. And data.whole scores is the value we want to set it to. And then we have the bind where we're passing in ID and then data.underscore ID. In this particular case, because we're passing in the ID, only one document's going to get updated. However, if we did collection.modify last name equals Stroz, then whatever value is being passed in as data.whole scores would be set for every round of golf in there where I was the golfer. So this is kind of like the where clause in an update statement. So it can be universal. So if we didn't pass anything in there, then every document's going to get that value updated. So just like you don't want to run updates without a where clause, you don't want to run modify without passing in information to filter out what it is that you want to update. So now we have the update score, and you'll see here's the ID, and then the whole scores is just the array of data based off of the score for each individual hole. And we click send, and we success equals true, and then we go back to verify it. So we're just going to call the same method again, which is get by golfer Dinglehoffer, and you can see now this is the August 30th, 2022. And now you can see the whole score data is actually there. So that's the C, the R, and the U. The only thing left is remove. So what we're doing here is we have a remove score endpoint that is a get, and it has an optional ID that we pass in, but we actually handle that here so that if we don't pass in an ID, a message actually gets returned saying, please provide a valid ID. But if one is provided, we pass it into the remove score method. And we call collection.remove. And then we pass in where underscore ID equals the parameter ID, and we bind that to the ID that's passed in. Again, if you call .remove and you do not have any information in here, it will remove everything. So you need to be really, really careful that you have the right criteria in here when you call remove. Otherwise, you're going to be restoring your document store database from a backup that hopefully you have. So then we have remove score, and you'll see up here we have remove score, and that's the ID that we gave that particular score. And when we click send, see it says success equals true. And then we go to verify. Again, we're doing get by golfer and passing in Dinglehoffer. And you'll see that now there are no scores for Skippy. And that's all the examples I have for tonight. Just to recap, we talked about the difference between NoSQL and relational databases and some of the pros and cons of both. We gave an overview of what MySQL Document Store was and what parts actually make up MySQL Document Store. We talked about the X plugin and the X protocol and how we use those to connect through MySQL Shell and through Node. And we had a bunch of APIs for talking about, we had a bunch of examples for the CRUD API, and we had a couple of examples of how we can actually leverage the power of raw SQL to run ad hoc queries against our JSON documents. And if anybody's interested in learning more about MySQL Document Store, there's a couple of links up here for the document store as well as for the connector for Node.js. And there's also a GitHub link for the code and the data for the demos that I actually showed while we're going through here. One thing that's not on here, if anybody has any questions when we're done here, or you're playing around and you're confused about something, you'd like some clarification, you can always email me at scott.stroz@oracle.com. Does anybody have any questions?
My only question is, what other nefarious activities do you use the alias Skippy Dingle Hover for? But you probably don't want to answer that on the recording.
Yeah, no, it's just that's like been my go-to made-up user.
Gotcha. Thanks very much, Scott. That was fantastic.
My pleasure.